So James, we are in this little meeting room with some kit on the desk, and we're here to have a look at really the evolution of failover.
Yep, absolutely.
Or resilience, really, right? Talk us through what we've got.
Yeah, so at the minute, we've got a customer device. In this case, it's Juniper SX300. And we've got a Peplink B1 5G that's connected via tunnel to the cloud that gives a public IP address to the Juniper. The Juniper's actually taken that address on itself, and that is the connection at the moment for it. And that's going out to the internet, which we've got there, a ping running, we've got a file copy going, and we've got an SSH session to an Ubuntu server.
Fantastic.
The reason we've got those there will come evident in a minute.
Okay, great. So customer firewall, and what we're doing here with the Peplink is doing what we typically do, which is delivering a public IP address to the WAN interface of the Juniper,
yep.
So that the customer can have a wireless connection to the internet over cellular or Starlink or whatever in a bonded way, and have a single public IP that connects all of that. Yeah,
yeah, absolutely.
Okay.
So what we can show on top of that is that we've done some configuration already on the Juniper device and on the Peplink device, but we're actually just going to add a secondary Peplink device, which is a different model, as failover for the Peplink.
Yeah, so the story we're trying to tell here is you have a solution deployed, which is the Peplink delivering connectivity over cellular and potentially Starlink too, if Starlink was plugged in. And what we're going to look to do here is deliver hardware resilience by adding an additional Peplink device to the Juniper, right?
Yep, absolutely. And the idea will be as well that we'll be having this still be the primary device, but this will actually be using a connection to the secondary device and be able to use all of the bandwidth from that as well as all the bandwidth from this.
Ah, cool. Okay, so this is, that's important, right? Because normally when we see hardware failover, what we tend to see is VRRP. And that was in that kind of configuration, you have a primary, a master and a slave, primary and secondary, and the secondary really doesn't do anything. It just waits to be called into action, doesn't it? The primary does all the routing. It's the WAN connections on the primary that are in use,
yep.
And the secondary is pretty much sat there idle until the primary fails. It detects it, and then it takes over the WAN links.
Yep, absolutely.
But what you just said there was we're going to have a primary, this one, that's going to be able to be in its primary role, but then also connect to the secondary device and use the cellular links that are on the secondary device as additional bandwidth. Absolutely. And for as additional links for resiliency.
Yeah, absolutely. And also it's WAN connection itself. So if we've got two Starlinks out there, and this has got one Starlink connected and that's got one Starlink connected, that will be able to use both Starlinks for its connection.
Fantastic.
Or in this case, we're using a fiber connection, so we're doing just that.
Yeah. Got it.
So just waiting for that to connect as this comes up.
Sure. So the BR2 is booting now, and it's it'll be warming up the OS, and it warms up the cellular modules, and they need to connect, and then we wait for it to do a health check. And then as that comes up, the Juniper will see what exactly? What will happen?
So the Juniper has a connection to the BR2.
Yes.
It will actually see that this is here. It will start talking BGP to it.
Mm-hmm.
And once that's up, it won't have a default route from it, as well as that having a default route, but it uses this as its primary.
Okay, great. So the Juniper knows that this is the primary, that's the secondary, and routing is ready to go and react to an event.
Yeah, absolutely.
Which I'm sure we're going to do something catastrophic in a minute.
Well, so I thought the first one is if we just get our colleague Emil on a call.
Oh yeah, good idea.
Bring him up in the corner there so it's live, and then what we'll do is we'll actually disconnect the primary and show the active failover to this, and the call will keep going. We'll drop a packet. The terminal session, which I can show is active right now by pressing enter a couple of times. You can see it's active.
Yeah.
You can type on it. There's a file copy still going on. It's got about 11 minutes to go, so as long as we get done within that.
That's a good challenge.
Let me just call Emil.
Yeah. Okay, so whilst you're doing that, I'll just go over it again. So we're pinging the internet. We've got a live SSH session to something on the internet, and we're downloading a file from the internet. So a bunch of different protocols, bunch of different servers involved, and now we're going to call Emil over Teams as well to see how that goes. There he is.
There he is. Hi, Emil. So we're just doing this as part of video recording just to show this work. I'm just going to bring me on the camera as well here, which may not load because I think the screen recording is using it.
Yeah.
You can hear me? Excellent. So if you can just keep yourself moving for a second, what we're going to do is we're just going to pull the power off the primary router and just demonstrate what happens and how quick that is. So if you can start moving for me. And on the count of 3, I'm going to pull that cable out. 1, 2, 3. So that's the cable now disconnected. Emil's still moving because that traffic's now failed over and it's running out of the BR2. We've dropped a single ping on there. The terminal session is still running, which on any other type of failover is terminal. And that terminal session would drop. So if you had users out there doing SSH, FTP, file copies, the file copy itself is also still running. And everything just keeps ticking and working.
So that was really cool, right? So single packet loss. We've affected completely. That's been ripped out of the network. So the primary gateway is gone. Everything is going through the secondary gateway, and it was pretty much seamless. We saw a bit of blip on the video. Otherwise, nothing else noticed, did it?
No, not at all. I mean, the file copy barely lost any speed. You know, it might have dropped slightly as it dropped a couple of packets, and then it just keeps going and it comes back up to full flow. And
That's really cool.
We'll hopefully have an inset running here while this video is going on when you're watching it, where we'll be showing what happens when it's doing just load balance failover and how that goes far more wrong.
Okay, that's wicked. Okay, so that was failover. What about failback?
So failback is just as easy. In fact, we'll possibly lose no more packets. We might get a little blip on the video if I can get the plug into the port.
Brilliant.
So what's actually going to happen is the reverse, essentially. So that's going to come up. It will start talking to the Juniper. It will start talking to the BR2. It will build its tunnels. BGP will establish, and then traffic will start flowing from the Juniper to the primary.
Okay, so there's a couple of things about this that are really interesting, right? The first one is the obvious difference in router. So we've mixed a Soho device here, plastic one with a rugged one.
Yep,
but it could be 2 rugged devices.
Yep.
And
it could be 2 2500s, the biggest device that Peplink do, and we're doing gigabits of bandwidth on this.
So this works for enterprise devices in a rack in a data center, but it also interestingly works for rugged devices working just over cellular in a vehicle or a drone or a remotely driven taxi or dump truck like we're doing in Brazil. So this is real serious, really serious capability here, which lets us do hardware failover for real-time traffic and make it almost seamless, right? You know, literally the video, we just saw a bit of a blip. That in itself is pretty cool. We haven't really talked about public IP addressing. We mentioned that we've got a single public IP that's arriving on the Juniper over the infrastructure that we've built here. But the key thing is that IP address didn't change. The IP address came from the cloud. Routing continues to be successful over it. And the IP address that we were using over the primary router is exactly the same as the IP address that we're using over the secondary.
Yeah, absolutely. So just to demonstrate that, the IP address that's there is a Venn IP.
Yes.
That's what I'm getting. I don't think I mentioned actually, I'm connected to the router.
Yes.
I'm NATed. I'm on a 192.168 address. I get NATed from the public IP address that this has got.
Mm-hmm.
That then gets passed out to both the devices.
Yeah, so your laptop's connected to the internet via the Juniper, which has got a public IP address from Venn Telecom's network. And importantly, when we fail over backwards and forwards, the public IP address doesn't change. And that is how the services continue to be seamless, right? Because although we've ripped out the primary gateway, the IP address doesn't change. So everything on the internet just sees traffic coming from the same IP as it fails across to the different device.
Yeah,
and indeed, when it fails back. I see we've got a green light on the front of the primary now.
I will check.
So I'm expecting that to have warmed up, to be warming up its cellular connections and doing health check.
Yeah, so that's actually all done. We failed back. Emil's still there. I don't know if we can find a packet loss.
No.
Maybe one. That's actually a lot earlier. When
that was much earlier.
I was powering on.
Fantastic. So as we were talking, we fell back to primary. We didn't notice. Emil didn't notice. Could you tell when it fell back?
Thumbs up or thumbs down? We haven't got any sound. He might not be able to hear us.
He's just waving. Everything's fine. Yeah. Very good. Okay. Well, as a demo, I think that's been very successful.
Yep.
We've shown, in summary, how we can deliver a public IP address to a customer firewall. We can add in a second router and the connectivity on it, bonded all together over a single public IP address,
Yep.
and then at will rip and replace the routers, primary or secondary,
Yep.
and whilst maintaining seamless connectivity.
Absolutely.
Brilliant. That's what we wanted to show.
Yeah.
Thank you very much.
No problem. Thank you.